Hello, if you are writing GCE this year, pay attention. I'm going to solve some likely questions to come out in your GCE this year on the alternative to practical sessions. Now remember, it's going to be computer-based tests. So all questions are going to be calculation-based to assess your knowledge on how to handle data you've obtained from your practicals and how to manipulate data to get some results. So I'm going to treat these questions with you carefully and gently so that you will master them before the D-Day. Um, I am creating this video due to requests to make a video on explaining how these questions can be answered. So let's go right into first question. So the first question says, in a titration experiment, 25 centimeter cube of 0.1 mole per dm cube sodium hydroxide is required to neutralize 20 cm cube of hydrochloric acid. What is the concentration of hydrochloric acid in mole per dm cube? Now let me quickly clarify something before we go into solving this question. First of all, sometimes you see mole only for concentration, and sometimes you see mole per dm cube. So always know that they are the same thing. I hope this is clear. Alright, so let's go right into this question. The first thing anytime you approach a calculation question is to try to bring out your data. It makes it very simple and it will make your work organized and easy for you to handle. So first of all, we have two things here. Of course, you know, in titration we have acid and base. So in the titration experiment, let's bring out sodium hydroxide now, 25 cm cube, and so the volume, let me give volume for sodium hydroxide, let's give it V1, is equal to 25. Okay, I won't be able to write the other things, just follow me carefully. Then we have C1 for concentration, which is the concentration of sodium hydroxide, to be equal to what? 0.1. Okay, so the next thing is required to neutralize 20 cm cube of HCl. So for HCl, volume is equal to, let's give this V2, 20 cm cube, 20. And the question is now, what is the concentration of HCl in mole per dm cube? So the concentration is now unknown, and that's what we asked to calculate. So do you see that we already have the values, the details we need for all our calculations in this question? So the next thing is now to think of what formula am I going to use, and there's urgent need for you to try and master the common formulas used in calculation. In this case, we are going to use C1 V1 is equal to C2 V2. So what this formula is trying to say is that the product of the concentration and volume of either acid or base is going to be equal to the product and the concentration of the other acid or base, depending on what you use for C1 V1 and C2 V2. So with this now, we will be able to calculate the concentration of hydrochloric acid by saying our C1 is 25 multiplied by, okay, this is our V1, of course. V1 is 25, C1 is 0.1. So this gives us equal to our C2 concentration is unknown. Let's leave it as C2 multiplied by 20, which is our V2. I hope you are following. So with this, we can make C2 the subject of formula so that we can have C2 is equal to, how do we make it the subject of formula? You know, it's by dividing both sides by 20. I hope you understood this simple mathematics. I don't want to do much of mathematics. This 20 cancel 20, so we have C2 is equal to 25 times 0.1 divided by 20. So we have 25 times 0.1 all over 20. So by the time you multiply 25 times 0.1 divided by 20, you are going to get 0.125 mole per dm cube as the final answer, making B to be the correct answer. So you can pause and use calculator to verify this value that we have gotten in this question. All right. If you have done that, let's go to the next question. The next question says, a burette reading shows 7.5 centimeter cube for initial, that's for initial reading, and 30 centimeter cube for the final reading. You know, when you are using burette, you have initial reading and final reading. So in this case, the initial reading was reading 7.5 and the final reading was reading 30.0 centimeter cube. Now, if the pipette used 25 cm cube of solution, what is the tighter volume? What is the tighter volume? Now, I'll explain this question to you because you are likely to come across something like this. They want to be a little bit tricky to see whether you've really known what you are doing. So in burette, you start from somewhere. Most times we start from 0.0 as our initial reading, but in this case it's starting from 7. So what is the titrant? What is the average volume? What's the volume used if you start from 7.5 to 30 and the pipette use 25 cm cube? So what you are expected to do here is that tighter volume is always equal to the final volume minus the initial volume. So this will give us 30 minus 7.5, and this will give us around 22.5 centimeter cube as the final answer. Is this not simple? Very simple, but if you don't know, you may not be able to answer this. So let me quickly go to another question so that we would solve 2 more questions and close for today. So try and get this very important. I have stated one important formula that you need to know, which is C1 V1 is equal to C2 V2. Most times in every volumetric analysis questions, you will have to use this formula, so please don't forget it. Alright, so the third question, I'm not going to write all the details, but I'm going to just pick a few things that I have here, and then so listen to me carefully, please. So the question says, from the table below, the results of the titration of 25 cm cube. So we have 25 cm cube of H2SO4 was used against 0.05 mole per dm cube sodium hydroxide. Now the table given to us is, we have burette reading in centimeter cube. So we have first reading, second reading, and third reading. So then here we have final and we have initial reading. So the first here we have 22.5, the second reading we have 22.4, and the third reading we have 22.6. Yes, so the initial here we have 0.0, 22.5, and of course 22.4. So this is the table we have for the experiment. So the question now says, what is the average volume of sodium hydroxide used? So we now need volume of sodium hydroxide used. So this is the question we are expected to tackle, and it is a tricky kind of question. Now, first of all, let me quickly say this. In volumetric analysis, most often you find out that, in fact, in secondary school, we are taught that you use burette for acid and you use pipette for base. Now, this is not always the practice. You must not necessarily use pipette or burette for acid and for base respectively. In some time, depends on the experimental design, you may require to put the base in the burette and the acid in the pipette. This is what exactly happened here. The acid was pipetted because the volume was already given to us initially, that in this experiment though, the amount of H2SO4 used is 25 centimeter cube, which means they know the actual. So the titrant was actually the sodium hydroxide, which was placed in the burette. So this was pipetted instead. So why I'm explaining this is so that you will not be confused and say, why am I seeing this? Is this not for burette and this for pipettes? No. Sometimes base is put in the burette and acid in the pipette. So you need to get this clear. So in this case now we are asked the average volume of sodium hydroxide used. So what I'm trying to tell you is that actually this data, these results here are for sodium hydroxide, and we are asked to calculate the average of sodium hydroxide used. So what do we do? You know, average volume of sodium hydroxide used is going to be the sum of these three numbers divided by 3, of course. 22.5 plus 22.4 plus 22.6 all over 3. Okay, so we have the options given to us. So all you need to do is to punch your calculator, find what we have here. So the options we have here are 1, we have 22.4, 2, we have 22.5, 3, C rather, this is B, this is C, 22.6, and D, 44.9, all in centimeter cube, centimeter cube, centimeter cube, centimeter cube. If you have done this, so what is your answer? I think you would get this as the correct answer. So I hope you got this. Let's now move quickly to the last question in this class before we call it a day. Okay, I would want you to master the formulas. The question we are going to solve now would also involve the use of formula, and this is very important. Once you can bring up the formula, I tell you, you will not be able to answer that question. I'm not going also to write everything in full, but I'm going to write key things that we may need to solve the question. First of all, the question says the molarity of sodium carbonate. Molarity of sodium carbonate is 0.2 mole per dm cube. Okay, the next statement now say what volume of this solution contains 0.1 moles. What volume of this same sodium carbonate will contain 0.01 moles of sodium carbonate. I hope you got the question clearly. I don't have to write all to make the video brief and short, yet clear. So we have the molarity. Molarity is concentration. It means concentration. So the concentration is 0.2 mole per dm cube. We have the volume is what we are now being asked. That what volume of this sodium carbonate for this concentration will give us 0.1 moles. Now I'm going to introduce a very important formula in this case, but before then let me write the options here. A says 25 cm cube, 25 cm cube. B said 50 cm cube. C said 100 cm cube. D said 200 cm cube. Yeah, so this is very important that you master. So now there is a formula that says molarity is equal to, okay, not molarity this time around, let me just write it direct. Okay, there are two formulas, you need to master both. So number of moles is equal to molarity times volume. Okay, This is one formula for calculating number of moles. Another, okay, before then, let's work this out first. So if this is the formula, remember we are given number of moles, we are given the concentration, which is the molarity, so we can find volume easily, isn't it? So let's cross multiply. Okay, let me make the formula very simple. Number of moles is equal to molarity times volume. I think this is very simple. So remember we are looking for volume, so let's divide both sides by molarity. Molarity will cancel molarity, so volume is equal to number of moles all over what? Molarity. And we have this, so we substitute to get number of moles is now 0.01 all over. What is the molarity? 0.2. This would give us 0.05 decimeter cube. Do we have this in our options? No. So by the time you change this to centimeter cube, you are going to have 50 centimeter cube. I hope this is very clear. So this is the kind of questions you should expect in your exams. In fact, there is no way you are going to write these exams without having this kind of calculations. The last formula I want you to master is molarity is equal to mass in grams all over molar mass. In the next video, I will try to ensure that I brought a question out of this so that you also know how the questions from this kind also usually come up. So molarity is equal to mass in gram all over molar mass. I have said I will bring a video on this, so but it's very important. So I've introduced 3 important formulas in total. The first one is C1V1 equal to C2V2. If you are writing WAEC chemistry, know this formula, very important. So we have 1, 2, and 3. So master these formulas very well, as you are going to do calculations that are related to this, all these formulas. So thank you for staying with me. If you have any question, if you need clarity on any of this, let me know. If you have any question, if there is other area that you feel it is also important that I should create a video on, please write in the comment section and I will work on that. I'm going to make a video also on qualitative analysis and other areas that are being tested in the alternative to practical sessions. So follow our channel, subscribe particularly, so that once I post a new video, you will be among the first to know and also come and learn as you prepare for your exams. Best wishes. Please, if this video is very clear, please write it in the comment section. If it is not very clear, just write also in the comment section that you need clarity on question 1, question 2, question 3, question 4, depending on the question you have not gotten clearly. Thank you so much. Once again, we meet in the next video. Bye.